Hey everyone, and welcome back for another deep dive. So, you guys wanted to hear all about dark comets. And, well, I gotta admit that the name alone got me super curious.
Yeah, they're not like those dazzling comets with the bright tails we usually picture.
Like the classic comet look, right?
Yeah, exactly.
So, what makes these comets dark then?
Well, basically, they're missing that bright coma we typically associate with comets.
The coma, that's that fuzzy cloud around the comet.
Right, exactly. And that's why they're so hard to spot. They kind of blend in, lurking in near-Earth orbits, much like some asteroids do.
Ah, so they're sneaky little things. But if they're so hard to see, how do we even know they're out there?
Well, that's where things get really interesting. We see these strange movements, these non-gravitational accelerations that just don't make sense if you're only considering the pull of gravity.
So something's nudging them around like cosmic bumper cars. Exactly. And the best explanation we have is that they're still active, still outgassing, just like any other comet.
But they're dark, right? Shouldn't we see some sort of activity if they're outgassing?
Well, the thing is, it might be happening on a much smaller scale than what we're used to seeing with great comets. Or maybe their composition is different, with ices that sublimate less dramatically. It's still a bit of a mystery.
So they're kind of like those quiet achievers, not flashy, but definitely doing their thing out there in space. Okay, but why should we care about these dark comets? What makes them so special?
Well, they might be tiny and hard to spot, but they could hold incredible clues about the early solar system. They're like time capsules, carrying secrets about the processes that shaped our cosmic neighborhood billions of years ago. They might even hold clues to the origins of water on Earth.
Okay, now you've got my attention. Water, really. So how do we even begin to unravel the mysteries of these dark comets? Where do we start?
A good starting point is understanding how these dark comets might form. And the leading theory is something called a rotational fragmentation cascade.
A what? That sounds pretty intense.
It is. Picture this. You have a comet, a big icy one, hurtling towards the sun. As it gets closer, the sun's heat starts to really bake it, and the ice begins to sublimate. Now, this sublimation, doesn't just create a thrust pushing the comet, but it can actually spin it up.
Spin it up, like a spinning top.
Yeah, kind of. It's like a figure skater pulling in their arms to spin faster. And as this comet spins faster and faster, it starts to feel the strain. And eventually...
It breaks apart.
Exactly. But the story doesn't end there. The fragments, those smaller pieces, they also start spinning and sublimating, and they too can break apart.
Wow, so it's a chain reaction.
Yeah, a cascade of fragmentation. And it keeps going until those pieces get so small that they're finally stable. They've lost most of their volatile ices, and they're just spinning there, small and tough.
So these dark comets are like the survivors of a cosmic demolition derby. That's a pretty amazing journey. But this is all just a theory, right? What evidence do we have to back it up?
Well, scientists have been piecing together clues, and there's a surprising amount of evidence that points to this rotational fragmentation cascade. For one, the size of these dark comets, they're small, just as the theory predicts. They've been through multiple breakups.
So their size is a clue. How small are we talking here?
We're talking kilometers across, sometimes even smaller. And here's the mind-blowing part. At these sizes, what keeps these dark comets from falling apart isn't just gravity, it's their material strength, like a tightly packed rubble pile.
So their size really matters, and their strength keeps them together. What other evidence supports this theory?
Well, scientists have actually calculated the material strength of these dark comets based on how fast they're spinning. And guess what? It matches up perfectly with the idea that they're Redl piles formed through these fragmentation events.
Wow, so they're like cosmic jigsaw puzzles held together by their own internal strength. Okay, I'm buying it. But where did these original comets, the ones that started this whole cascading breakup, where did they come from?
Now, that's where things get even more interesting. To answer that question, we need to look at the bigger picture, the dance of objects in our solar system. And it turns out there are two main suspects in this cosmic mystery.
Two suspects. All right, now intrigued. Lay it on me. What are these two possible origins for these dark comets?
Well, on one hand, we have the Jupiter family comets. These are classic comets full of volatile ices, and Jupiter's gravity can fling them inwards towards the sun. But then there's another possibility, the main belt.
Wait a minute, I thought the main belt was full of asteroids, not comets.
You'd think so, right? But it turns out the main belt isn't as dry as we once thought. We found objects there that show comet-like activity. They're called main belt comets, or MBCs for short.
So there are hidden comets hanging out amongst the asteroids. That's incredible.
It is. And some dark comets, their orbits, suggest they might have come from a specific region of the main belt, a place called the inner main belt. There's this gravitational sweet spot there called the E6 resonance, and it can act like a launching pad, flinging objects out of the main belt.
So it's like a cosmic slingshot, sending these objects on wild adventures through the solar system.
Exactly. So we have two main suspects, JFCs flung inwards by Jupiter, and those originating from the main belt, possibly launched by this E6 resonance. But how do we figure out which scenario is more likely? That's the million-dollar question.
It's like a cosmic game of Guess Who with these dark comets as the mystery guests. So how do we solve this mystery?
Well, researchers have been meticulously studying the orbits and characteristics of these known dark comets, trying to see which origin story fits best. It's like trying to put together a giant cosmic puzzle. And there's one dark comet in particular that has really stirred things up. It's called 2003 RM.
2003 RM, what makes this one so special?
Well, its orbit is really different from most of the other dark comets we've found. It's kind of an outlier, a rebel. And some scientists think it might have come from the outer main belt, which is really surprising. That region isn't usually known for having comets. 2003 RM is also significantly larger than most other dark comets, which might mean it hasn't undergone as many breakups.
So 2003 RM is like the black sheep of the dark comet family, challenging everything we thought we knew about where these objects come from.
You could say that. It's a real puzzle. And it just goes to show how complex and dynamic our solar system is. The more we study these dark comets, the more we realize there's so much we still don't know.
I love how much we've learned about these dark comets already, their hidden nature, their possible origins, and how they might even challenge some of our assumptions about the solar system. But looking ahead, what does the future hold for dark comet research? Are there any big discoveries or missions on the horizon?
Oh, absolutely. There are some really exciting things happening that could totally revolutionize our understanding of dark comets. We've got new, more powerful telescopes coming online that'll be able to detect fainter objects, maybe even a bunch more dark comets. But the most exciting development is a mission that's going to give us a front row seat to one of these amazing objects.
Ooh, a front row seat. Now you've really got my attention. Tell me more.
Get ready for Hayabusa 2 TAG, an extension of the incredible Hayabusa 2 mission, set to rendezvous with a dark comet called 1998 KY26 in 2031.
We're sending a spacecraft to a dark comet. That's amazing.
It is, and it's going to be a game changer. Hayabusa 2 TAG is going to give us the most detailed data we've ever had on a dark comet. We'll study its shape, composition, rotation, even its internal structure, all up close. Imagine we'll be seeing one of these mysterious objects face to face.
Incredible. What are you most excited about with this mission?
Well, the possibility of getting samples is just mind-blowing. Imagine having pieces of a dark comet right here on Earth. We could analyze its composition in ways we can only dream of right now. It would be a scientific treasure trove.
Samples would be amazing. I can't wait to see what Hayabusa 2 TAG reveals about these dark comets. It feels like we've only just scratched the surface of what there is to learn.
Absolutely. These dark comets have already challenged so much of what we thought we knew, and I have a feeling they still have many more surprises in store for us.
I agree. And on that note, let's take a quick pause to let all of this sink in. We'll be right back to continue our exploration of the fascinating world of dark comets. All right, so before the break, we were talking about the origin of these dark comets, and it sounds like we've got a real cosmic mystery on our hands.
Yeah, it's a bit of a puzzle trying to figure out where they came from. To do that, we really need to look at the big picture, the whole population of small bodies in our solar system, how they move and interact.
So like a giant cosmic dance.
Exactly. And to try and understand this dance, scientists use these super sophisticated computer models, to simulate the effects of gravity over millions of years.
So it's kind of like rewinding the clock, tracing the paths of these dark comets back through time to see where they started.
Yeah, that's a great way to put it. And what those models are telling us is that there are two main suspects when it comes to the birthplace of these dark comets.
Two suspects. All right, this is getting good. Who are the usual suspects in this cosmic lineup?
Well, suspect number one is what we call Jupiter family comets, or JFCs for short. These are the classic comets we all know and love, full of volatile ices. And Jupiter, with its massive gravity, can sometimes fling these comets inward towards the sun.
So it's like Jupiter's playing a game of cosmic billiards, sending these comets scattering across the solar system.
Yeah, kind of. But then we have suspect number two, which might surprise you, the main belt.
Hold on, the main belt. I thought that was the domain of asteroids, not comets.
That's what we used to think.
Hmm.
But it turns out the main belt isn't quite as dry and boring as we once believed. There are actually objects there that show comet-like activity, We call them main belt comets, or MBCs.
So there are comets hiding out amongst all those asteroids. That's incredible, but how is that even possible? Shouldn't those ices have all sublimated away by now, being so close to the sun?
Well, it's possible that some of those objects in the main belt, they might have formed further out in the solar system where it's colder and then migrated inwards over time. Or maybe they're just really good at holding on to their volatiles, protected by a layer of dust or something.
So they're like little time capsules, preserving those ancient ices from the early solar system.
Exactly. And what's even more interesting is that the orbits of some of these dark comets, they suggest they might have come from a specific region of the main belt, the inner main belt.
The inner main belt. Is there something special about that region?
Yeah, there's this gravitational sweet spot there called a index resonance. Basically, it's a place where Jupiter's gravity can really mess with the orbits of objects. Think of it like pushing a swing.
Pushing a swinger.
Okay, I'm listening.
You know how if you time your pushes just right, you can make the swing go higher and higher? Well, that's kind of what the index resonance does. It can give those objects in the inner main belt a little gravitational nudge, enough to send them on new, wilder trajectories through the solar system. Ah, so it's like a cosmic launching pad, flinging those objects out of the main belt and potentially setting them on a course to become dark comets.
Exactly. So we have these two main suspects. JFCs flung inwards by Jupiter, and those originating from the inner main belt, maybe launched by that index resonance.
Yeah.
But how do we figure out which scenario is more likely? Which of these cosmic culprits is responsible for creating these dark comets?
It's like a giant cosmic game of Clue, except instead of Colonel Mustard in the library with a candlestick, it's Jupiter or the index resonance with a comet.
Uh-huh. I like that analogy. And it turns out there's one dark comet that has really thrown a wrench in our investigations. It's called 2003 RM.
2003 RM. Okay, what's so special about this one?
Well, 2003 RM, its orbit is kind of weirdo. It doesn't quite fit with the orbits of most other dark comets. It's an outlier, a rebel.
Yeah.
And some scientists think that maybe, just maybe, it came from the outer main belt.
The outer main belt. But I thought we said that was mostly asteroids.
Yeah, it is. But 2003 RM, it's breaking all the rules. It's also significantly larger than most of the other dark comets we've found, which might mean it hasn't gone through as many of those fragmentation events. Maybe it's a more pristine example of what those early comets were like.
So 2003 RM is like the Rosetta Stone of dark comets.
That's a great way to put it. It's challenging everything we thought we knew about where these objects come from and what they're made of. And that's what makes it so exciting. It's a reminder that there's still so much we don't know about our solar system.
I'm loving this cosmic detective work. But speaking of things we don't know, I can't help but wonder, what does the future hold for our understanding of dark comets? Are there any missions or discoveries on the horizon that could shed even more light on these enigmatic objects?
Oh yeah, there are some seriously cool things in the works that could totally change how we see dark comets. For one, we've got these next-generation telescopes coming online, way more powerful than what we've had before. They'll be able to spot those super faint objects lurking in the darkness, maybe even uncover a whole bunch of new dark comets.
So we're going to have even more suspects in our cosmic lineup.
Exactly. But maybe the most exciting thing is we're actually sending a spacecraft to visit one of these dark comets.
Hold on, we're sending a spacecraft to a dark comet.
You heard that right. The mission is called Hayabusa 2 SHAG, and it's actually an extension of the already amazing Hayabusa 2 mission. They're planning to rendezvous with a dark comet called 1998 KY26 in 2031.
2031, that's not too far off. What will they be doing out there?
Hayabusa 2 SHAG. It's going to give us the most detailed look we've ever had at one of these mysterious objects. We're talking about studying its shape, its composition, how it rotates, even what its internal structure looks like. Imagine a close encounter with a dark comet.
It's like we're finally going to meet one of these cosmic enigmas face to face. What are you most looking forward to with this mission?
Well, honestly, what I'm really hoping for is samples.
Samples? You mean bringing back pieces of a dark comet to Earth?
You got it. Can you imagine having actual pieces of a dark comet right here in our labs?
Yeah.
We could analyze its composition in ways we can only dream of right now. It would be like a time capsule from the early solar system.
Okay, I'm officially geeking out now. Samples from a dark comet would be absolutely incredible. It feels like we've already uncovered so much about these objects today, and it's exciting to think about all the new mysteries we're bound to uncover.
Yeah. And the more we learn, the more we realize how much is still out there waiting to be discovered.
Yeah.
It really makes you appreciate the vastness and complexity of our universe,
It really does. And speaking of appreciating the vastness of the universe, I think that's the perfect segue to talk about one of the biggest questions of all the origins of water on Earth.
Ah, yes, the age-old question, where did all this water come from? And you know what? Dark comets might actually hold a piece of that puzzle.
Really? That's fascinating. I always thought that comets in general, those icy wanderers, might have played a role in delivering water to Earth early on. Could these dark comets have been part of that ancient bombardment?
It's definitely a possibility worth considering. Remember, we think these dark comets, they're fragments of those larger, volatile, rich comets. So even if they've lost some of their ices along the way, they could still have contributed to Earth's water supply. It might not have been a huge amount, but over millions and millions of years, those tiny contributions could really add up.
It's amazing to think that these small, dark objects, drifting silently through space, might have played a role in shaping our planet and making it the watery world we know and love today.
It really is. And it just shows how important it is to keep studying these seemingly insignificant objects. They can tell us so much about the history of our solar system and maybe even about the origins of life itself. Who knows what other secrets they're hiding?
It's amazing to think about how these seemingly insignificant objects drifting through space might have played a role in shaping our planet.
Yeah, it really makes you realize that there's so much more to these dark comets than meets the eye.
We've talked about their hidden nature, their possible origins, and even that incredible mission to actually visit one. But there's one question that keeps coming back to me, and I'm sure our listeners are curious about it too. What about the origins of water on Earth?
Ah, yes. The age-old question. Where did all this water come from? It's a question that has fascinated scientists for centuries. And you know what? Dark comets might actually hold a piece of that puzzle.
We've always thought that comets in general, with all their ice, might have played a role in delivering water to Earth early on. Could these dark comets have been part of that ancient bombardment?
It's definitely a possibility. Remember, we believe that these dark comets are fragments of larger, volatile, rich comets. And those larger comets, they were probably major players in that early bombardment.
But if dark comets are mostly devolatilized, meaning they've lost a lot of their ice, how much water could they have realistically delivered?
That's a good question. Even if they're not as icy as their parent comets, even a small amount of water ice delivered over millions and millions of years could have made a difference. Plus, we're still learning about the composition of these dark comets. They might harbor more water ice than we currently think.
So the jury's still out, but it's definitely possible that these dark comets played a role in making Earth the watery world we know and love today. That's a pretty incredible thought.
It is. It really highlights how interconnected everything is in our solar system. By studying these dark comets, we're not just learning about these fascinating objects, we're also potentially uncovering clues about the very origins of life on Earth.
It's mind-blowing to think that these small, dark objects lurking in the shadows of space could hold such profound secrets about our planet and our place in the cosmos.
It's a humbling reminder that there's still so much we don't know about the universe, and that even the most unassuming objects can hold incredible surprises. Who knows what other mysteries we'll uncover as we continue to explore?
Well, that about wraps up our deep dive into the world of dark comets. From their stealthy nature to their potential origins and their possible role in shaping our planet, it's been an incredible journey of discovery.
I've had a great time exploring this topic with you.
And a huge thank you to all of you for tuning in and for suggesting this fascinating topic. Keep those questions coming and keep looking up at the night sky with wonder. There's a whole universe out there waiting to be explored.